Hello there. My name's Stuart Carley, and today I'm going to be talking on my cookie cutter is broken. So a little bit about me. So I'm a network specialist practitioner. I work for Fujitsu Systems or Services. I'm a Fujitsu Distinguished Engineer, and I specialise in wireless networks. I also do a lot of routing and switching and IP telephony, so I'm pretty broad, but my main focus is in wireless these days. I've been at Fujitsu Services now for about 14 years, and before that I was at Cisco Systems and worked in the multi-service TAC team, and I did that for about 3.5 years. So CCNP routing switching, and at the moment I'm working towards the CWNE. One day I'll get there, but at the moment it seems to be taking a back seat because of the work. But that's the way it is. So, we'll move through it, and that is yours truly doing a site survey. Notice the Echo How. You can't see it on the picture. It's the Echo How and the wireless LAN professionals. Great pieces of kit. And in that particular, I was in Holland doing a survey in a warehouse. A very, very large warehouse for a very large clothing company, and which is now fully working. Right, so move on. So my cookie cutter has broken. So this is what I tell my customer quite often. Whenever I actually go and meet a customer, I talk to him, and I usually get this attitude, well, I have wireless at home. Surely it doesn't matter where you go. But then I start to explain to him or her that when I go to different companies and see different scenarios, I go to a warehouse, or I've been to a warehouse where the signal is so poor, they've got all their APs lined along one wall of the warehouse, but the signal at the other end of the warehouse is so poor that their devices can't work, or they work very, very, very poorly. And the moment they get any more than maybe 3 or 4 pickers in the actual aisle, the signal completely gets destroyed. And also, because they were trying to get the signal so far down the aisle, they've turned all the power on their APs to full power, and everything is causing interference with each other, and their performance is not particularly brilliant. So then look at a pub chain, for instance, and they decide that their method of AP placement is what is the easiest way to run the cable? Right, I can run the cable along to there, I'll put an AP there. Or it's that beam is probably going to be in the way. So what I'll do, I'll put the AP the other side, or I'll put it on a wall. I'm not very keen on putting APs on walls, especially Omnis. Yeah, one of my pet hates is putting Omnis on the wall. It'll work, but the gain of the APs, like for the ceiling, for the wall, it's not actually going in the direction it really needs to go. So things like that I start to take. I get to a coffee chain and work with a coffee chain, and they decided that their idea of wireless is a single router, with the 2 antennas at the back, and it's embedded in their office at the back of the shop. So all the customers having to sit at the back of the shop to be able to get any decent wireless, if they get any decent wireless, because of the actual walls between the office and the actual shop is so thick that they're getting probably a negligible signal. Or I go to another coffee customer, and they've decided in their wisdom that they're actually going to place Omnis in their roastery. The only problem is that their roastery ceiling is nearly 60 foot off the ground. Yeah, so and I go, well, that's going to work. So these are the sort of things I explain to the customer. And when we start looking at cookie cutter, I can't even say it, cookie cutter type network design, we either have too little APs, too many APs, which then we get coverage holes, we get CCI, growth channel interference. We get all these sort of problems, and in the long run, this will cause more costs too. So there's so many things that we need to keep into account. The type of building that we're actually going to be looking at for an office, whether it's industrial or warehouse, whether we're doing internal or external or a mixture of both, and the materials that these buildings are made. So, for instance, a pub chain that I work with, they might have, because they've been working with the, running a cable, putting an AP there, that might work fine in a new build, but half their pubs are 300-year-old cottage-type buildings that have 3 foot thick walls or things like that. So these are the sort of areas there. Another area that I get dragged into is vendor oversell. So your vendor will come along and they'll sell to the customer and say, you need this many APs. And the reality is they don't need that many APs. They only probably need half the APs. And also they'll probably sell, you need the best AP that you can possibly buy. But their equipment wouldn't even make a difference if they've just paid half the cost and bought the middle range of the AP. So I have to really work out their vendors. And of course, the other area I hit a lot as well is change of use. So I might go to a customer and they say, I want to do this. And I just want a guest network. So you work out a design for a guest network. And then 2 months down the road, they've moved 200 people in, 200 developers in the same area, and they're all doing database work. So these are sort of areas that we actually look at. So we look at different things that need to be taken into account, and a cookie cutter scenario doesn't work because we need to look at every venue, every design differently. So, as we saw, the pitfalls of various different designs, long-term costs over short-term gains. So, for instance, the pub chain that I work with, now they're having to effectively go back to every single site and actually do a proper survey. That's cost them more money. If they'd done it in the first place, or they would follow our advice, they would have saved themselves a lot of money in regards to having to do a proper survey now. Obviously, poor performance, again, this is going, I've mentioned before in regards to the warehouses. Again, my other conversation with most customers is the fact of vendor marketing. The vendor will tell you something in regards to a particular AP, and he will say, it will do 1.4 gigabits per second. But you only have to start to educate the customer in regards to that may be on a good day with all the planets aligned on a Tuesday and on a leap year in the year 2020. So we have to educate them to say, well, that's not actually necessarily the choice. And this all comes into the area of design and the impact of you as a designer and your contact with the customer. So the next thing, wireless theory 101. Now, this is a particular thing that I like in regards to talking to my customers. And what I mean by that is this. I'm going to catch that. I like to engage my customer and talk to my customer in regards to the basics of wireless theory. And the reason why I do that, so we go through all these different particular areas. We talk about basic RF, how RF works and the projection of the electromagnet. Different. Obviously, we've talked about 2.4, 5 gig and frequencies and stuff like that. So we'll go through that. We'll talk about MCS tables and the importance of the signal-to-noise ratio and the fact that you can tell them, or try and get them to understand what it means by noise floor and the difference between signal strength and the two gives you the signal-to-noise ratio and how important that is to be able to get good throughput and speeds. We look at AP types, whether it be an omni, whether it be a directional, depending on the situation that we're actually going to be looking at in regards to design. Whether it be an industrial, which case quite often it will be a patch antenna, a more directional sort, or obviously in an office it might be omni. And of course my pet, as I said before, my pet getting an omni on the ceiling rather than on the wall. We'd also look at different things like multipath, like for instance the warehouse people that I actually worked with before. One of their major problems was the fact that the kit was so old that they suffered from a lot of multipath issues because a warehouse, lots of metal, they were using non-N devices, so it's B, G, so they were suffering from multipath quite a bit. So these are the sort of things that we actually looked at, and the difference between CISO and MIMO and N and different rates. Notice the picture here. This I got this idea from Keith. Yeah, these are all different slides that I take with me when I go to a customer and I talk to the customer, because it helps them understand where I'm going and what I'm talking about in regards to wireless design. So I have all these laminated sheets, and I will pull them out if I'm explaining something to a customer, and they really do appreciate that. Something, some visual aid that can show them how it's doing. So the crux, the reason why I do this is because better customer knowledge leads to better decisions and better results in the long run in regards to your wireless design. Because once an informed customer, they are much more open to change. And it allows a better design cycle. And by that, what I mean is this, is that quite often you might go to a customer and you'll say, I want to do this survey or that survey. And they go, well, I don't want to pay for that. I don't want to pay for you to go to my site and do a survey. But once they understand the importance of what that survey may be, whether it be an initial survey or whether it be a later, we'll look at that shortly. So, once we've started to get a customer who's got better engaged, we can start looking at what sort of requirements we look to gather. We look to get to the floor plans. We mentioned floor plans. We usually mention the floor plans for the actual predictive design. Now, I put that there, get the floor plans early as possible for two reasons, right? First of all, depends on what side of the business you are. First of all, if you're sales, yeah, it might be useful to get the floor plans in regards to getting an accurate BOM. So, you know, if you're doing maybe a bid for a particular customer that might have maybe 3 or 4 sites, or it might be big, it might be many sites, you might be able to get a handful of floor plans for particular various flavours of the buildings that they have, and that would then give, with a quick predictive survey, would give you a good idea of the BOM that you would need to be able to put for a quote. So that will give you a more accurate BOM, and they would save you money and save the customer money in the long run. That's the first idea. But secondly, in regards to getting the floor plans easy, if you don't get the floor plans early, it can seriously hose up your design. The reason being is that you start to go into the design process, and then you find, this happened to me a couple of years or so back with a hotel, that because we came into the design process late, it turned out that the hotel had already been built, and that means then because of legal rules, fire rules and stuff like that, once the walls are up, they're sealed. So that means then you can't run cables, and that means then you're seriously stuck in regards to where you can place your APs. And usually in a hotel, that means where? In the corridors, yeah. And that means then you get a poor performance in regards to your network design. So I always say, get the floor plans as early as possible. Next thing I start looking at is like top 10 clients. Rather than going to the customer and saying, what devices do you use in your network? Because when you start to look at a more of a generic thing, a lot of times the customers will struggle in regards to, well, how many, we've got a whole load. But if we start to be a little bit more specific and say, well, what are your top 10 client devices? And which of those top 10 clients are actually, is the least capable? So the top 10 critical devices that you use as a business, and which is the least capable. So through these we can start to work out how we're going to work out capacity, what sort of approach we're going to use, what sort of roaming type. Are we using VoIP phones? Are they actually mobile in regards to that, or they're more laptop based? I mean, there could even be, these days you can have desk phones that are actually wireless. Or it could be a PC with a wireless connection. It could be a number of different devices. Is voice required? Is it link, or is it just, like I say, it was a voice handset? Do we have mobiles connect? Do they swap from 3G, 4G to wireless calls when they actually enter the things? All these are in the mix in regards to working out our capacity, along with whether we need a guest network or applications that we will use as well. So, if you looked at requirements, we're trying to work out an idea of the capacity planning that we're on, what sort of clients we're using, because as we know, in wireless, client is king. Client effectively does everything in wireless. The APs are there to service the clients, but the clients dictate everything. They dictate whether they, the roaming behaviour. They also will dictate the number of the rate of data, because there might be, it might be a phone. This is a 2-stream, so this obviously will be the data rate on this will be a little bit faster than an older phone, which will be a 1-stream. It could be most laptops are 2-stream. You might get the odd Apple or Windows Pro, Surface Pro, which might be a 3-stream. So it's the client who will actually dictate what sort of speed. Well, that and the air, the quality of the air as well, which would indicate whether you were going to get the speeds you want. So client is king. So we really need to understand how that works, and then we can then sit down, work out our capacity, and then we can move and start looking at the actual survey itself. So the initial, for me, the initial survey would be, with the first site visit, would be a pre-predictive survey. So I wouldn't have actually done a predictive survey at this point. I probably would more likely go just to get a feel of the buildings or building that I'm actually going to be doing the design for, and just maybe take a few samples, because we were talking about the different thicknesses of the walls. If you take it straight off plan, might not necessarily be what we think is on plan itself. So quite often you can think, well, that's a dry wall, but actually in reality it's not a dry wall, it's actually got brick inside. So it gives you an opportunity to be able to take RF samples in regards to the building. So the picture I had on the initial introduction, we were looking at the offices there, and the offices were, the walls were actually solid concrete, but the design plan didn't look like it was solid concrete. Actually, we just thought they were just normal drywall. So it gave me the opportunity to be able to go to the site, to be able to get a feel of it, and also at the same time, I usually take in my toolkit a little Buffalo AP. I don't know if you know them. You've seen these little Buffalo APs? They're about that size, with a battery pack, and then I can set it for 2.4 or 5. Set it at a certain speed, a certain sort of power level, and then with either an app on my Android phone, or using the G2 air checker or something like that, I can then check the actual dB loss, the attenuation of that particular piece of material that we're actually the wall. So it does a good idea of what materials you are using, that's being used in that building itself. I also like to do a spectrum scan to be able to see whether there's any non-802.11 interference, just to get a feel what's there. So it might be that there could be some issues in regards to non-802.11, whether it be motor, large industrial motors or something like that might be causing the problem that we could possibly overcome in the design to be able to make a better service in regards to the Wi-Fi. As well as doing a normal spectrum scan, I would actually do a part of that would be just doing a normal 802.11 scan itself as well, just to get a feel of what's going on around the neighbours, right? So if I'm in, I go to London, I've come to London quite a lot. I go to a middle of the city, and I'm going to do a survey of a particular building or a particular floor. You know you're going to get lots of network, especially on the 2.4. I mean, I did a survey in Holborn a while back, And I think I picked up nearly 60 different networks on that from doing that scan, 60 different 2.4 networks. There was an occasional 5 gig network, but majority were 2.4. That's going to have a major impact on the performance of a 2.4 network on that floor. So you have to take that into account. It'll give us an idea of what, and then we can go back to the customer and say, look, you're not going to get a good performance here. We really should recommend don't try not to use 2.4 if you can get away with it. Go to total 5 if you can, because obviously that might impact in regards to the equipment they're using and the devices they're using. They may have devices on 2.4 that they can't change, and obviously that then restricts the choice. So we've done a pre-predictive survey. Then I will do a predictive survey, and I'll look at the survey, and like Yussi was saying earlier, it's not necessarily set in stone. Once you do the survey, it doesn't mean to say that you're going to work off it. Again, that picture that I had on the screen earlier was one of the jobs we were doing there. Is we'd already done a predictive survey of the actual warehouse, but there was a couple of areas that we were really not quite sure that we were getting the right feel from the tool. So one of the things we did was to actually do an AP on a stick survey. Now, I don't know if does anybody do AP on a sticks surveys? Yeah. So that's what we did. We went out and did an AP on a stick survey. So we actually placed an AP in the area, roughly in the area that we got on the predictive plan, and then we just went round and we actually surveyed to see what the difference was. And there was a bit of difference. So we then adjusted our AP placement to actually match that to get a better performance. So we got to the point now where we've done the install, we've put the APs on, and we start to do a validation. And this is one thing I can't emphasise more than anything else, and that is to, if you can get the customer, and this is why I like to get the customer on board from a technical point of view, even if they're non-Wi-Fi technical, they might be network techie, but not Wi-Fi. To be able to get that iterative process in regards to the design process, to be able to go, this is what we've done. We've done a predictive. We've done an IP on a stick. We've honed it. We've installed it, and now we want to validate it to be able to get the best performance for that particular customer. So we often do that. I've done this 2 or 3 times. Again, this customer I was talking about in London, where I actually went with a colleague, and we actually probably did a validation to probably 4 surveys of validation, just to make sure that we've got the best. There was added complexity, because I was saying we've got 60 different networks around it, but at the same time the customer decided in their wisdom that they were actually going to place 2 different vendors wireless in the same office. So we had to be able to do it in a way that their own network wouldn't interfere with the other network. So we had to do a more validation in regards to that. And that means then we can change it, we can do a passive scan. And the other thing that I quite like to do as well is that if I can, we was talking about the top 10 critical devices, if I can get a hold of a customer's least, critical but least capable, whether it be a tablet or a phone, whatever they may be using, as part of the validation, I will actually do a test with that particular piece of kit. Because often when we use Ekahau, and our tools, we've got big ears. Yeah? So that means then, quite often, we would say, oh, that's cool. But because they've got big ears, they can hear it better. Whereas the phone or the tablet may not be hasn't got such big ears, and therefore the performance may not be as optimum as we'd like it. So I like to take a client device as well with me. And at the same time, I also quite like to have a look around, see what's doing. For instance, you realise that your naming convention is not quite as it should be and needs to be changed. For instance, so these are the sort of things that pick up. And can you see it? You can't see it. For those who can't see, it actually says WB CR AP You do the spelling. Yeah. So we had to change the naming convention because, I mean, on paper it looked all right, but as soon as you actually looked at it on the actual AP, that had to be changed quite quickly. So let's look at another area that actually is as important as the actual RF design, and it's something that quite often gets overlooked. Yeah, we have to understand the network requirements as well in regards to when we're working with a customer, because obviously this underpins everything that we do, whether it be wireless, whether it be a voice, a telephony solution. The network underpins everything. And one of the things that I found with wireless and telephony is that perception is everything. Perception is everything. If you roll out a solution, however good, and the underlying network is basically not up to scratch, the first thing they'll be going to say is, this wireless sucks, this telephony sucks, and it's not actually the telephony or the wireless solution that's bad. It's actually the network. It's the network that underpins it. It's actually bad. Would it be, So we really need to keep a focus on that as well, because also that will add costs as well to the customer, because the customer might say, I want all these APs, but they don't have any power over Ethernet switches. So we might have to, they might say, well, you're going to have to refresh your switches because you haven't got any PoE. Yeah, or things like cable runs, whether it's in industry wireless. When you're actually in a warehouse, you've got long cable runs. It's not going to hit the 100 meters, so you're going to have to start running fibre. Then you've got power issues in regards to putting cabinets in various different places, whether it's high up or low down. So all these things need to be taken into account as you design as well. Network systems also is an area which you actually keep an eye on. I mean, things like DNS and stuff like that, especially if you're doing, if you're doing a public event, something like, talk about the Super Bowl a lot, things like, and the football grounds and stuff like that. DNS is really, really important because everything uses DNS. Everything's doing lookup against, you go into Facebook or you're going to Twitter or anything like that. bbc.co.uk, you're using DNS. So if that's not up to scratch, that could be causing problems. I want to also talk briefly about tech refreshes, wireless tech refreshes, because that's one area that I get involved in quite a lot as well. More so perhaps than actually greenfield soils. And that's doing a passive survey. So it's worthwhile doing a passive survey if you can in regards to a tech refresh to see what's actually there. Obviously, you're going to get a feel of what the neighbours are like and whether they're impacting on the customer, but also from the sense of get a feel of what's going on in the air. So quite often I will take an air sample, and when I mean by an air sample, it will be like either OmniPeak, or if you want to use Wiresharp with the NXP cap dongle, but that is quite expensive if you piece of kit. But somewhere we can take a sample of what's going on in the air to see what's actually happening. So it could be that their wireless design actually isn't too bad. It might be okay, but the problem is that with a certain tweak, that their performance could be raised, and they don't actually need. Now, it's not good for your sales guys, but it might be that we could help them out in regards to working out. So, for instance, I actually did a survey with this pub chain that I'm working with and their headquarters, and when I actually did an air check, the actual coverage was okay. And one of the issues was capacity, and this is what I was saying, that originally it started as a guest, but then they started moving in 100-odd people just to do development work. But when we actually did the air sample, you could see that a lot of devices were losing, they were having 70% retries. So it was just rubbish. And with a little bit of thought and a little bit of knowledge in regards to that, we could then adjust that network and then give them a better performance without even having to actually change their their actual network, maybe with a few APs extra. So that would make a difference. So it's a good idea to be able to do that as well, just to get the feel for the tech refresh. So lastly, I just want to talk about future trends. And I know Brett's going to talk about this a bit later on, but it's one thing that came to mind when we start looking at wireless designs. Yeah, most network access these days is by Wi-Fi, yeah? Yeah, whether it be in a coffee shop or whether it be, I mean, I go to my head office, which is just down the road, and literally you can walk into the office and you will see somebody with a laptop at their hot desk, and they're on wireless, and literally there's a Ethernet cable about 3 inches away from their actual laptop, but they don't use it. They just literally walk in and fire the wireless up. So even if they had the access to Ethernet, majority of the people actually just log on using the wireless. So most network access these days is by wireless. So when we start to move out, and we're thinking about this as a company as well, in our own corporate sense, is that are we now starting to look at pure wireless in our greenfield sites or in our tech refresh? Yeah, because from a greenfield site, it can save thousands and thousands of pounds, because then you haven't got to do all the cable runs, or very limited number of cable runs. You haven't got to get so many switches, because obviously all that's needed is the actual ports for the APs and maybe a handful of non-wireless devices, non-critical wireless devices. If I get that right, non-critical wired devices that are connected to the network. So that means because there's no cable runs, that saves a lot of money. It saves almost like 4/5 of the cost of the actual greenfield site rollout. Which sounds, well, that's a no-brainer, isn't it? No cable runs, lower switch count gives massive cost savings. But the thing is that it actually requires requires a cultural change in regards to how the company works in regards to how they roll out their IT support. So their desktop support, they have to be wireless savvy. They have to have the appropriate tools as well, and to be able to work out, because now we've gone from doing a Wireshark on a port or whatever it may be and be able to fix an issue. But when we move then to just a wireless, it's there, it's invisible, it's in the air. We don't know what's going on. We need to be able to basically, first of all, sample what's going on, and secondly, then understanding what's going on from the sample that we've taken. And then therefore we actually understand at a lower level what might be causing an issue. Whether if it's retry rates because we're getting a lot of corruption in the air, or maybe something else. So the actual troubleshooting of our corporate areas maybe is a little bit more. Again, what I was saying earlier, generally the client is king. So therefore we have to have more emphasis, because we want reliability, that there is no more the backup of an Ethernet port. You can't plug in an Ethernet port if it's not there anymore. So you're on wireless 100%. So it has to be to enable a good performance, to be able to get the right pieces of kit. So that might then lead to a narrowing of the equipment that we use in the actual corporate sense. It'll be certain laptops, certain devices, certain NIC cards, certain drivers, so that we know that we can get reliability and good performance through that, because that's how we're going to get our business done. No backups, no Ethernet ports, and the design needs to be spot on. And that's it. Thank you very much for listening. Any questions?